Hi, I'm Ms. Gergen, and today we're going to talk about coronavirus as an exponential growth function. So a lot of the times you guys are in school and you ask your teachers, Miss, when am I ever going to use this in real life? Well, if you understand exponential growth functions, you may be able to see how it applies to the coronavirus and why we are currently doing distance learning and practicing social distancing. So let's take a look.
Okay, so exponential form. What does exponential form look like, right? So exponential form can be written in the form a times b to the x power. So you can see that here. You can also see the shape of the graph. It kind of starts off flat, horizontal like, and then it shoots up. So that's the scary part about exponential functions. If we don't control the situation, it can grow extremely rapidly and get away from us, right? That's not happening because we have been on top of it and we are taking care of it and being safe. Now, this A and this B, which feature of the exponential function does the A term represent? So A, that first number in the equation, represents your y-intercept. And if you know about your y-intercept in real-world situations, that also represents your initial value or your starting value, right? So how many coronavirus cases did we start with, right? There's going to be that patient zero, which means there is that one person that brought that to the US. So we started with one case, right? Okay, now that's the A value, which is our initial value. Now, what does the B term represent? The B that has the variable on top of it as an exponent is the common ratio. Okay, so common ratio is what we are multiplying by. So at what rate is coronavirus multiplying in the United States? Well, let's take a look. So as per the Washington Post, I found this statistic. They've gathered data. This is what is out there right now. So for coronavirus infections, the doubling time in the United States has been about 2.5 days. That means that on average, the number of reported COVID-19 cases doubles every 2.5 days, doubles. So doubles means that what is our common ratio? What is it, this virus multiplying by? 2, right? Doubles, 2. Now, this is occurring every 2.5 days. So let's take a look at two graphs here. I made two equations. One's correct and one isn't. So first of all, let's define our variables. When you're writing an equation or a function, you always want to define your variables. So we're going to let P of t represent the population testing positive with COVID-19 in the United States. I should have written that. Let T represent the time in days, right? Now, we already talked about where this 1 and where this 2 comes from, right? The 1 is our initial value, that first person that brought it to the US. Ooh. Our 2 is the fact that coronavirus is doubling in the US. Now, T represents the time in days. So if I plug in numbers to this T, you can see I already graphed it here in red. It is this red graph here. And as you can see, it is growing much faster than the blue graph. The blue graph is where I divided the t by 3, okay? Because this is the time, this doubling is occurring every 3 days. So I want to divide whatever I plug in there by 3. Okay, so the blue graph is flatter, as you can see, so it's growing a little bit slower. They kind of start at the same place right here at the origin, right? We read from the origin 0, 0 when there were 0 cases and we hadn't started documenting yet. But if it was doubling every day, it would be the red one, which is crazy because that shoots up. And the blue one's a little bit flatter. And that's currently the equation that represents our situation in the US. So we are going to use this equation here, P of t equals 1 times 2 to t divided by 3 power, because it's doubling every 2.5 days, which I rounded to 3 for the sake of the example. Okay, my computer is frozen. Okay, sorry. So let's make a prediction. So why do we want to be able to make an equation? We want to be able to make an equation or a function, write a function, because then we can use that function to make predictions, right? And we want to know what's going on in our world right now, right? And we can kind of calculate it on our own. So let's take a look. Using that equation, how many positive cases will there be of COVID-19 after 12 days in the United States? So 12 days, minuscule, it's pretty quick, right? Again, exponential functions start slow and then they grow very rapidly. So let's take a look. So we're going to plug in 12 to t, as t represents the time in days. So that's what this is going to look like. P of 12, right, instead of P of t equals 1, because that's the initial value, the first person that had coronavirus. Parentheses, so times 2, because it's doubling in the United States. And then to the t divided by 3, I plugged in 12 to the t. So using order of operations, what are we going to do next? You may be seeing parentheses, but look inside the parentheses, right? The parentheses are only holding the 2. So there are no operations that need to be done in the parentheses. However, in the exponent, we do have some math we can do. We do have 12 divided by 3. So 12 divided by 3 is 4. So we got to simplify that. But we still have an exponent. And what is the base of that exponent? The base of that exponent is 2. So we need to do 2 raised to the 4th power. Remember, that means 2 times 2 times 2 times 2. So that's going to give us 16. And then lastly, we can multiply. 1 times 16 means 16, or equals 16. So we have P of 12 equals 16. What does that mean? What does that mean to you in a real world context? So bring it back to our example that we're talking about, right? We're talking about coronavirus in the United States. In parentheses there, we have a 12, but initially it was a t, right? So that means that must represent time. So this means that after 12 days, there will be approximately 16 positive cases of COVID-19 in the United States. So not too bad, right? But again, exponential functions grow slowly at first. And then, let's see. Let's take this out a little bit further and predict it 2 months from now, 60 days from now. 60 days is approximately 2 months. Okay, so how many positive cases of COVID-19 will there be after 60 days, right? This is if nothing is done, of course. So let's take a look. Let's plug in 60 to t, as t represents our time in days. So as you can see, I have switched the 12 to a 60 because we want to make a prediction of how many cases there will be in 60 days. So P of 60 equals 1 times 2 raised to 60 divided by 3. Order of operations, we're going to work in that exponent and divide 60 by 3, which gives us 20. We still have to deal with that exponent, so 2 raised to the 20th power. That is 1,048,576. And we multiply it by that 1, that initial case. And that means we have P of 60, that's how you read that, P of 60, equals 1,048,576. So what does that mean? This means that after 60 days, there will be approximately 1,048,576 positive cases of COVID-19 in the United States. That is crazy, right? It grew pretty quickly. Now, as per the CDC, let's look at some stats here. Literally went on the CDC website, cdc.gov, and as of April 22nd, 2020, there are only 828,441 cases in the United States. So does that mean that we are wrong? Or why might the number of cases be lower than predicted? Right? So let's think about that. We're saying that in 2 months, and it's been in the US about 2 months, there were supposed to be 1 million. Does it mean we did it wrong? Or what could be happening?
So hopefully now after watching this video, you guys understand why we are currently in distance learning and practicing social distancing, because had we not done anything, this virus would have continued to spread exponentially, very rapidly, and by staying home, we have been able to keep the number lower than normally anticipated. Hopefully, you guys understand the importance of this and continue to learn online. I know it's a challenge for all of us, your parents, your teachers, you guys, but it is worth it. And hopefully, you're able to calculate other exponential growth functions on your own in the future. Thank you for watching.